From HanselMinutes.com, it's Hansel Minutes, a weekly discussion with web developer and technologist Scott Hanselman. This is Lawrence Ryan announcing show number 292, recorded live Thursday, November 10th, 2011. Support for Hansel Minutes is provided by Telerik RAD Controls, the most comprehensive suite of components for Windows Forms and ASP.NET web applications. Online at www.telerik.com. In this episode, Scott talks with Henrik Nielsen about the history of HTTP and the World Wide Web.
Hi, this is Scott Hanselman, and this is another episode of Hansel Minutes. And today, we're sitting down with a pretty interesting person, Henrik Nielsen. He is a Danish engineer and computer scientist, and he did some really interesting work early on the World Wide Web. How are you, sir?
I'm pretty good.
So, you and I are within 5 years of each other's age, but I think while I was fooling around in high school, you were getting your master's degree in engineering in Denmark. And then you met an interesting person when you went to work at CERN. Can you tell us a little bit about that?
Yes, I a long time ago, when I was a student, I figured out that it is very convenient to travel out and do things as a student, because you can sort of just drop in a place and then be there for a little while and leave again, and have some great experiences. And so I looked around actually to where to do my master's while I was at my Danish university. And I talked to somebody who knew a guy who was sitting at CERN, and say, well, this guy is doing some interesting stuff. We don't know exactly what it is. He's calling it something web, but it's very interesting. So you should go talk to him. So I went down, and CERN is on the Swiss-French border, just outside Geneva. And so I went down there and visited, and I met Tim Berners-Lee, who that was back in '93. He had formally proposed the web as a concept in '89, I believe, and was working with. There were 2 or 3 students, sort of associated roughly with his group, plus a couple of CERN people, plus Tim. But that was about it. There were about 5 people all in all. And so he was very enthusiastic. He said, "Yes, great, come on in and sit down." And that's how I effectively started working on the web. So I had to go back and pack my stuff and all that kind of stuff. But I came down in basically January '94, moved to CERN as a technical student, and then started working on web technology as it was being developed. And very specifically, it was about working on a code library called libwww that has the old sort of Unix naming style, that had the first HTML browser. It has some HTTP implementation. Most of it was actually done by Tim himself, plus another guy that helped doing some of this stuff. And I helped and continue developing this together with another student from Finland. And that's how the CERN server sort of came to be. There was something called the Limo browser and other kind of things. And then after a little while, I think it was in March, March of '94, where the first web conference ever was held. And it was held at CERN. And there were about 300 people. And that was the entire community who knew about the web in the world, effectively. So Mark Andreessen was there, a few other people from around the world have been looking at. There were some other browsers at that time. There were people who have been putting up websites. Slack, Physics Labs has also put up a website. And so that was it was very exciting, sort of be part of that gang of 300 or so people, basically with everybody who had been either putting up a web server or starting writing browsers or working on servers and those kind of stuff. And that's how it pretty much started.
So at that time, you said there's about 300 people in the room, and that's basically everyone on the planet that knows everything about the web. Are there less than 300 websites at this point?
Oh, yes. At that time, Tim basically had a little web page where he wrote the there was the first index of web pages, and it could stay on a single page. So there were not a lot.
So it was just a page that was like a list of all the other pages on the internet.
Yes.
So
and that website was called info.cern.ch, which was the place where the initial specs, where this page of websites and a bunch of other information was posted for a long time.
When you first heard about this idea of the web, I assume you were using Telnet. I mean, I remember at that time I was probably using something like CompuServe, and I was, dialing into universities and telnetting around. And even before that, I was using bulletin board systems. Was there a sense, or were you already drawn to the idea of an interconnected group of computers?
I didn't quite realize the power of the interconnectedness in a global scale, because it's hard to get a grasp until you sort of see it. I was immediately taken by the idea of this information space that everybody can participate to produce information and to consume information and to exchange information and to have a common place for talking about things. I think that was a very exciting idea. I think one of the times where it kind of clicked, sort of personally, was really when you started. Was both on the website, but also just with using email on things that you could send emails. For example, one of the times, and now it sounds of course naive, is that there was a Unix guru called Stevens, who wrote some very good Unix books for networking and for the TCP stack and whatnot. Mm-hmm. And I was reading that because I was programming some of the stuff in this library, and there was a piece of DNS that I couldn't understand what it was doing. And so he had his email in one of his books, and so I sent him an email, which was kind of like I might as well send off a probe to Mars, because I had no idea sort of what the person was and where it was. And he answered, and that was kind of saying, "Oh my goodness, this is really powerful. This is being able to communicate." Obviously, while this was an email, the web sort of took that to another level. It was something that I think many people sort of they have an internal realization saying, "Oh my, this is really powerful," and then you get on board, and then there's just no going back.
So that's one of those moments where you realize that this is going to be a thing.
Yes, absolutely.
So you worked with Tim Berners-Lee and the W3C, the World Wide Web Consortium. Yeah. And now, when I think of the World Wide Web Consortium, I think of it rarely. I think of it when I have to go and dig deep into a specification to find out whether or not something works the way that it's supposed to work. And I often find myself poking around inside of the HTTP specification and saying, mm-hmm. Was this intended to do this? And you were one of the primary authors of that. How does that work? You just sit in a room and think it up, or is it a series of meetings? And when you're off inventing something like HTTP and writing it down to the byte detail, where are you and what are you doing when this is happening? Well,
the way I'd say it is that it's a understanding very early on that this is a collective effort by a lot of people, and that it's not very much somebody sitting and dreaming up mm-hmm. the idea. I would say obviously Tim dreamt up the initial idea and how the protocol can work, but mm-hmm. there's a lot of details for whether you should using so basically, should you use, what language should you use to describe what is the format, what is the syntax, what is the semantics around it, and there's a lot of choices, and effectively they are always engineering compromises. Mm-hmm. It picked early on sort of email style headers. It's called RCA22 headers, which has sort of name colon value as being the language of HTTP. Mm-hmm. That was introduced in HTTP 1.0 Before that, it was actually just a one line which said get and then the URI that you want to get. There was no metadata around it. So all those kind of things, I'd say, evolved. It was not somebody sitting locked in a room thinking about it. It was writing code, interacting with people, seeing what the scenarios were, very much being part of a vibrant community where people wanted to do. Then, for example, HTML forms came about. So post was dealt with. I remember one detail. For example, doing put, you can obviously do put content up to a web server. And in 1.0, what we had was that you just send the document with the put up front. And I was doing some experiments where I was sitting at that time. I was sitting moved to MIT with the Web Consortium. But we were still playing around with a server back at CERN, so I did put cross-Atlantic. And we realized that sometimes if you do an authentication and you got sort of back, you said you're not allowed to post the document over here, you could actually lose the response the way that HTTP was formulated. So we had to add something called a second little, this is what these 101 temporary or 100 continue messages was introduced to HTTP in order to get around those kind of things. So many of those things were really, obviously there was some fundamental, the way I say it is that you come up with some basic principles that you would like to adhere to. Some of them was that it's document oriented, that is hypertext driven, that is based on URIs, and that is stateless. That means that is you don't have sessions, you don't have anything like that. And once you sort of pick your set of principles up front, then the rest of it is about filling in the gaps and figuring out how does this work, and how does that work, and build code. And one of the things that I think has always been at heart of both IETF and also W3C. W3C is sort of inherited from IETF.
IETF, of course, being the Internet Engineering Task Force for folks that may not be familiar with that acronym.
Exactly. That's where the typical sort of RSC acronym comes from. That those are documents that are published by that organization, and they also have published published TCP and IP and DNS, and effectively they are to the internet to what the World Wide Web Consortium has been to the web in terms of sort of driving the core specifications. And the key piece there has always been what is called rough consensus and running code. That means that you get into a room, you don't agree on everything, but you have rough consensus for saying this is roughly the right thing, and then you basically have two or more implementations that work together. So you have to demonstrate that things work. And that is a great way for getting beyond my thing is prettier than your thing kind of discussions, where you can discuss that till the cows come home. At the end of the day, is really the focus has always been, yes, that's great, but we need to have running code. You need to demonstrate that it runs not just in your lab or between two machines, but can run globally. And that's where you can't just sit down and think that through. There are too many variables and too many unknowns and too many quirks that you have to work with. And so it really takes a community to come up with a spec. And I think HTTP was very much developed as a community. There were the basic principles that they started out with what Tim had in terms of sort of the basic things that we just talked about. But on top of that, it's really about the community pitching in, saying this is great, but why don't we add this? Why don't we add that? And then it rolls from there. And so effectively, the most productive and most successful specification work that I've been part of have always been where the working group has been working in tandem with developed implementations. So it's not that the working group goes out and dreams about something up and then the implementations come later. It's really the implementations and the specification go hand in hand.
That's really a fascinating idea, because it should be a guiding concept for everything that we design. I think that there's a lot of times when people spend hours and hours in front of a whiteboard brainstorming things and then being very congratulatory once the whiteboarding is done. But you're right. Yeah. Once you have an implementation, you're only half done. But, two complete working implementations, presumably written by different people talking to each other, is a really great way to confirm that things are working as you specified them and as you imagined them. And certainly no better way than to find the bugs in the specification than to actually try to implement it.
Yes. And in fact, the HTTP specification work has actually just recently undergone, right now as we speak, undergoing a big editorial revision. It's called the HTTP BIS work, which is updating the HTTP spec with a lot of clarifications about how things work by deployed implementations already. There might be places where the spec is unclear, so there's a lot of things that's being cleared up. But in a sense, the critical aspect of it is that the spec becomes more of a historic document than because it kind of captures what is working, what is out there, what is available today, and that's, I think, is the critical aspect of what a spec should be. It documents what is out, what is working. That's what it should be doing. If it defines and say every time you do something you have to go to that document to figure out what the idea was, then you don't have this interaction between deployed implementations and the specification.
This episode of Hansel Minutes is brought to you by Careers 2.0. Careers 2.0 is a new service by our friends at Stack Overflow. You're probably all familiar with Stack Overflow, the online Q&A resource dedicated specifically to programmers and programming-related topics. Well, the team at Stack Overflow created Careers 2.0 to provide you with access to great jobs and introduce you to a bunch of great companies that you might consider working for, even if you're not currently looking for a job. Think of Careers 2.0 as a programmer profile. It gives you a platform to show that you're awesome by featuring your proudest contributions to Stack Overflow, GitHub, SourceForge, Bitbucket, anything programming related. You can even add your favorite programming books from Amazon.com. Profiles on Careers 2.0 are free. They're easy to get started, especially by importing your LinkedIn profile. However, there's one catch. Profiles on Career 2.0 are invite only. They did this to keep out the spam and have a high-quality environment. Fortunately for you, as a Hansel Minutes listener, I've got your back. Head on over to careers.stackoverflow.com/HM to accept your invitation today. Once again, that's careers.stackoverflow.com/HM. I hope you like it. How many times, now you probably know that specification backwards and forwards, because even though, it was a huge community effort, you're kind of the note taker and the facilitator, and you're actually typing up, one of the principal authors typing it up. How many times have you discovered that you thought you had it completely solid and you thought the spec was clear, and there's a section of the spec that is completely and totally unclear and then is being fixed, 10, 12, 15 years later?
I'd say that actually is by far the most common. It so happens that what somebody feels is clear turns out always to be unclear to somebody else. Mm-hmm. And in fact, one of the key pieces, and this is one thing that is rarely appreciated as part of a working group, mm-hmm. is that as part of going through a working group, and the HTTP working group was big at some point. I think it was probably 100, 200 people, not all participating, but sort of reading and sometimes pitching in and doing, mm-hmm. But sort of having good suggestions and other kind of things. One of the key aspects is that it's a collective education of that group of people for getting shared context for what this document actually is supposed to mean. Because you can only write it up to a certain point in English. There'll always be questions about, how does this work if you do this, and the face of the moon is exactly that, and those kind of things. And what happens is that the group of people of 100 or so, through this process, absorb part of the specification, and then they go out and implement it also. And it kind of grows from there. So it's not, we try, of course, to capture a lot of that in the document, but there's also a tremendous set of knowledge in the email aliases and just in how people get a better understanding of what's going on.
This might be an ignorant question on my part, and forgive me, but do you ever feel like you're surprised that it works?
Well, the way I'd say it is that I think some of the design, in a sense, I was very lucky because I did not have any internet experience. I did not have any distributed computing experience when I started working on the web. So I really didn't come in with a preconceived notion of saying, well, but this is not a distributed object system, or this is not a distributed file system, or this is not transactional, or I didn't have any of those sort of preconceived notions about what would work or not. And I don't think there was ever any question that it would work. It was clear that there were a lot of discussion about whether the protocol was clunky and whether it was wasteful. And I had lots of discussions with other people who had developed other solutions that were very technically, you can say, more elegant in certain ways. They were separated better out. They had, for example, one of the things we never did in HTTP is you cannot send responses out of order. So when you send a request on a single TCP connection, the response has to come back before you can send another request. And we never sort of say, well, I can send two requests, and then I can get the last request, the response first, and so I can get them out of order, which can have some significant performance optimizations. We never did that because that would break existing HTTP implementations. But there were other solutions that went down this route and went that way. And you could say from a network optimization, from a usability point, sort of from a network usage point of view, they were better in certain ways. What I learned, though, is that that's not really what matters most. What matters most is that you provide value to what people want to do. And this idea that you could just start a web server, point it at a file share, and now serve those documents, whether those were HTML documents or PDF documents or whatever else, or images, you could just serve them, was a tremendous value to the community and to people who wanted to expose information and to create information. And so this idea that you could build things that were more elegant, more efficient, all those kind of things is true. But what I learned is that never try and sit in front of have this efficiency argument if the solution is just to put in another server. If you if you sit in front of the brute force and say, well, if I just put in another server, I'm fine, is a very hard argument to say, well, but if you change your infrastructure completely, you don't have to do that. That is a very hard argument often to do because the value of the network goes up exponentially with the number of nodes participating in it. And as soon as that one combination takes off, the value of the network becomes huge. And so changing out from that way of communicating is almost insurmountable. So in a sense, you can say, well, it is funny because I was at many conferences where I heard, especially from TCP transport people who were objecting to how, especially HTTP 1.0, used TCP, which was kind of wasteful in many ways. And they say that I had many arguments saying, well, it's a stupid protocol because it does use TCP in the right way and it doesn't do this, and it has big request headers of many, many hundreds of bytes per request, and responses are also wasteful and those kind of things. And while that's all true, the alternatives were not able to break the momentum of HTTP simply because the value was too high. And that's I think a very useful lesson that you can. Engineering is a practical way of building stuff, and sometimes you have the luxury of doing things multiple times, but often when you come up with something, it really is a balance between the level of entry, how complicated it is to get up and running your system, is a huge factor in the system taking off. And if it has the right properties, then performance is something that can come down the line.
That is a powerful concept, and the idea that people want to be agile, and people talk about agile methods, but sometimes doing a big spec up front and really thinking deeply about it and doing small prototypes is a very valuable way to get something done. It may come out looking like big design up front, but it was actually a number of small iterative things. Like you said, you can do performance a little bit later, but would you say that these kind of specifications in the internet itself was done in an agile way? Because if you look at something like HTTP, it hasn't really changed in a while. I mean, things sit on top of it, but the essence is still there, 14 years later.
Yes, no, the essence is absolutely there still. And also all the quirks are there. For example, even today, there are 5 or 6 ways that you can, in fact, delimit an HTTP message, how long it is, which from a sort of a pure protocol point of view seems excessive. Normally you say, well, can I just have a byte count that I need to read in one place, and then I can understand when the message is one message ends and the other one starts. But HTTP doesn't have it. It has 5 ways. And the reason for that is because, well, it started out not having any way whatsoever, and then we had to add ways to it, and there were different ways of adding it, and some were successful and some were sort of quasi-successful, and so, but they all stuck, and so now we have this aggregation of various features, and you can come up with something that from a clean slate that is much more efficient in many ways from that perspective, but it's going to be an uphill battle to convince everybody to change.
So you went to work for Microsoft in '99 after you left the W3C, and what have you been working on lately?
Well, the web has stayed with me, or I stayed with the web throughout my career in one way or the other, because I'm fascinated by the potential and the overall idea and the ability for people to communicate and exchange information. I think is extraordinary. What I'm doing at different times has been kind of expanding where you can use the web technologies. One aspect that I was working on a couple of years ago was building robotics frameworks, where you can say, well, what has robots to do with web technology? But it turns out that you can use a lot of web technology, a lot of ideas behind how document-oriented, using URIs, being able to inspect by putting a browser and looking at what's going on, matches very, very well with something like robotics. And so I've been trying to push web technology into new areas where traditionally it hasn't been part of it. Robots were great fun. They are just near and dear to my heart, because they are the fact that they move around make your laptop look so much less interesting. Things that move around are just interesting, more interesting. And they also they taught me a bunch of interesting things about other aspects that Microsoft has been looking into a lot, like enterprise computing with reliable messaging and transactions and those kind of things. And some of the things we learn is that, well, if a robot rolls off a cliff, no amount of transactions or reliable messaging or any of those kind of things that typically have been deployed in enterprises work, because the robot is gone and you have to figure out, what are you going to do now? That actually works great with web technology, because the web technologies always say, well, we're going to do the best effort, but we're not going to just stop working if a server is down. We're going to try and do something else. What I'm doing now is trying to take the same ideas for building web platforms and merging it into cloud scenarios where we can provide a much easier way for you to build web APIs in particular. One of the things that we're focusing on is that the initial sets of web servers were either file servers or they were HTML. They were wrapping HTML around back-end processes. They could either use CGI, which was like this old way of communicating with the back-end process, but the back-end process generated some data, and now the web server's responsibility was to put HTML angle brackets around that data and then present it so that it could be consumed by a browser. HTML5 and JavaScript has changed that in the sense that what happens now is that a lot of the rendering can happen on the browser side. So the server doesn't have to put HTML around the data. It just exposes the data as what we call web APIs, where you can now program directly against these APIs that give you, and then build all the rendering as part of your HTML5 application. And so that means that there's a big push towards building these kind of new applications because they can be consumed both by browsers, by mobile devices, and across the board, across a set of devices that might render things differently, but now they can do the rendering locally rather than having the data coming and the presentation coming straight from the server being tailored to that device. And so what I'm working on now is to provide a new framework, which hopefully will be available in the not too distant future, where we can show some of the ways that you can build very lightweight, very efficient web APIs using the full force of HTTP, where you have sort of great access to headers and to methods, and you can set caching semantics. You can set whatever you want to set all around, and it has just an overall great experience for you to build these APIs and deploy them into the cloud.
One last question I always wanted to ask someone who works so closely on the internet is if you could explain to myself and to our listeners what HTTP status code 418 is.
I don't even remember what that one is.
You might be familiar with it as it's related to RFC 2324, the Hypertext Coffee Pot Control Protocol.
Yes, indeed. Yes. So Larry Messenger, who was the working group chair, followed up on a proud tradition in IETF for writing what is called April Fool's specifications. I think it goes all the way back to the 70s, 75 or 76, where the first of those were published. And they had, over the years, they actually had great sense of humor. One was one of the ones I remember is to send electricity over IP, which of course is an inherently impossible thing to do. But it was all about sort of doing things that at the front actually looked plausible, but did something that ultimately didn't make sense. The messenger had this great idea of writing the coffee pot control protocol as an HTTP protocol, and he published it as an April 1st April Fool's joke. And I think there was actually a great, and I believe it is, at least in RFC 2616, it is one of the formal references. If you look very carefully at the back of the document, it is actually referenced as a formal document supporting the HTTP 1.1 specification.
And the 418 status code is in the spec right now as you search for it.
Oh, it is in the spec right now. It's great, perfect. I love it.
Yeah, people can check those out at April Fool's Day RFC.
Yeah, and the thing was that it actually was so that you could in fact build it as a protocol. It was not just a thought experiment. You could actually do it, and I believe somebody has done it. I seem to remember somebody posting that they actually implemented it and had a little webcam so you could show the state of the coffee pot. Yeah,
it's much more fun if you're going to do something like this. You need to actually implement it. Someone in 2009 proposed doing IPv6 over a social network. So someone ended up implementing it. There's no reason not to. So they ended up implementing IPv6 over Facebook itself. Yes,
and you could. There's all of those things are absolutely. And the thing is, on one hand, they are great fun because they poke sort of poke fun at the layering and the modularizing, using modules for thinking about the protocol stack. Because of course you can always take something that sits at the bottom, say IT, and then put it at the very top of the stack. But it actually is a testament, if you think about it, to how the layering kind of works. Because it works because you can take something that sits at the bottom and is independent of what is both below and above, and you can then put it in you can reshuffle the stack and put it in another spot in the stack and get, and still make it work. Of course, from a practical point of view and performance point of view, it doesn't work, but it's a good lesson in that it kind of tells indirectly that the layering works.
It does, and that really is the testament to the web itself. It works, and we appreciate your role in helping make that. Henrik Nielsen, thanks so much for chatting with us today.
Thank you so much. It was great fun.
This has been another episode of Hansel Minutes, and we'll see you again next week.